Hey, how's it going? So I'm looking at a integral of an sort of a linear divided by a quadratic, and this quadratic happens to have a 2 in front of it for a lead coefficient, which complicates it a little bit. So first step for this one is to take the denominator and write it down, and then find its derivative. Now take that derivative, 4x plus 2, and write it here. And now our goal is to multiply it by an a and add or subtract a b, such that when it's all said and done, it equals the numerator, which is an x, okay? So I'm going to go ahead and do that. So I want it to equal an x, all right? And so if I want it to equal x, maybe if I multiply it by 1/4, that's going to help, because 1/4 times 4 is just an x. But now I have this 2 here, right? You need this 2 because it's the derivative. So if I multiply this 1/4 into this 2, then what I end up getting is a half. But I don't want that half. I want just x. So right now I've got x plus a half. So if I subtract a half here, right here, oops, let me erase this. If I subtract a half, then basically what I've got is exactly an x, because 1/4 times 4x plus 2 minus a half is x. And so all of this is equal to the numerator. And not only that, it contains the derivative of the denominator. So that was our first step there. This is a little thing here. So remember, what you need to do is simplify this thing to test to see if you're correct. It should equal the numerator. So if you simplify this, it should equal the numerator. Okay, so now all of this stuff is equal to x. So I'm going to get rid of that x and replace it with that stuff. All right, now I'm going to separate this integral out. And so I'm going to keep this section and the negative 1/2 over to here. This, I'm going to factor out my quarter. I'll deal with this integral later. I'm going to factor out my quarter, all right, leaving me this is now a very simple integral because it's the numerator is the derivative of the denominator. And so we know that that uses the natural log rule, okay? So and then your 1/4 stays out there. So that one's done. And I'll carry that down until the final answer. So now let's deal with this integral. So the negative was from here. The 1/2, I'm going to go ahead and pull that out, okay? And now I'm left with 1 over a quadratic, but this quadratic has a 2 in front of it. So when you do these ones, you're going to have to complete the square, okay? This is supposed to be a square here. So complete the square. That's what this is, right? So kind of keep that. And so when I complete the square, I like to not have a coefficient here. So I factor out my coefficient. If I factor out a 2, then this 2 gets factored out as well. And then this 3 becomes half as big. And so it's 3 over 2, right? And now this thing could be completing the square. Remember, completing the square is you take this number, 1, you cut it in half. So now it's a half. And you square it. So the square of a half is a quarter. And you add and subtract that quarter. Now, this first section here becomes my perfect square trinomial, which ends up equaling this square binomial squared. And now this plus 5 over a quarter is simply just these two guys simplified, okay? And now I've got almost what I need, but this 5 over a quarter needs to be written as in the format of a square, because I've got the something squared plus something else squared format in the denominator. And we know if we have that, we get to use this integral rule. Something squared plus something else squared is equal to that, is equal to this, okay? And this is a standard formula. And so now I basically rewrote that like that. So now this guy, I've gone ahead and completed the square. And not only that, I've made sure that this final trailing term is the square of something. Now I can do my substitution. Oh, by the way, I want to address these green numbers here. Notice this 2 here. Imagine this 2, it got factored out and it got, in a way, sort of written right here in front. And then what I'm going to do is I'm going to factor it out and write it over here, okay? And then basically the 2 in the bottom plus this times this 1/2 gives me that quarter. So that's where that quarter comes from. And now finally I make my substitution. X plus 1 goes in here. And then after you simplify these complex fractions here, the product of 2, a quarter, and 2/5 it becomes all of this stuff. And there, this is just a simple U substitution with a trig function.